So SOA, or Service-Orientated Architecture, defines a way to make software components reusable via service interfaces. These interfaces utilize common communication standards in such a way that they can be rapidly incorporated into new applications without having to perform deep integration each time. So this is just one of the many definitions of service-orientated architecture, and in a nutshell, it just refers to the modular design of task-specific functionality in a system. So you design your system with different modules, and these modules should be able to be added and removed and altered without actually affecting the entire system. And a growing trend with today's sort of ecosystem of software is that many services and platforms are built from the get-go with integration in mind. So it's not a zero-sum game. If someone can implement a use case and you don't have time or you don't have the resources, why not just expose the functionality as a service, and those external people can go pick that up and build their bespoke functionality when they need it, and this won't have anything to do with your system. All right, so now just to go a bit deeper, a service has 4 properties. It logically represents a business activity with a specified outcome. So it does something, it takes in something, does stuff, and returns an outcome that we know about. Secondly, it's self-contained. It doesn't really matter what happened before or after. These processes or services should be able to run in isolation, and you should be able to test these without relying on the steps afterwards or before. And then thirdly, it's a black box for its consumers. So when you use these services, much like using a programming package that you add on and reference, you don't really need to know the underlying functionality. All you need to know that it does work and what are the results going to be. And then fourthly, these might consist of multiple underlying services. And again, you don't need to know what these do. They just need to return what you need to work with. So now, to give you an idea with a non-technical example, I'm going to give you the example of me trying to run a pizza restaurant. So now, starting a pizza place involves quite a lot of few things and a whole bunch of moving parts that all need to work together. So one case, you need the raw ingredients. You need to get the farmland, and you need to get some ingredients. You then need to transport these ingredients in a nice packaged manner and process them. When they arrive at my shop, I can get my chef to then put these all together and end up with a pizza. I then need to arrange some way of getting payment for my pizza and then ultimately delivering that pizza. So now, if you looked at this from an in-house development point of view, you could try to control the whole flow. So you could buy your own farm, you could drive there every week to collect your raw goods, you could then process them, you could handle your cash in-house with no records on the books, and then you could deliver the pizzas personally. And there's nothing wrong with that. If you want to control everything, that's fine by you. If it's your only store you want to do, then that's also fine. But looking at this from an SOA perspective, there's a number of things that we can change here. So rather, instead of using all these different things and me controlling everything, I can just make use of third-party services which achieve each of the primary steps in the process. So the sourcing of raw materials and transport to my store can just be taken care of by an external food logistics company. And then payment processing and delivery can be handled by something like Uber Eats. So I only really need to focus on my making of delicious pizza. So now each of these steps is encapsulated or enclosed in a black box. And I don't really need to know how the logistic company gets the food or how Uber organizes the payment. All I need to know is that the food will get delivered to me, and I'll be able to give the delivery guy a box of pizza. So I don't have to spend time controlling or understanding the flow. I can just trust that each of the components will do what they're expected to do. And now the advantages of this is that, say I wanted to scale up and expand my pizza franchise. So I wouldn't have to do a deep build on every site and sort of retake in that whole chain of processes. Rather, I can just make sure my locations are set up at each of the locations, and then I can just plug in a logistics supplier, a payment handler, or a delivery service into my new location. This could be the same service provider, but how I've designed my pizza restaurant is that it shouldn't matter on the payment provider or the delivery or the logistics. Only that my core business process will not be affected. So now, just to summarize SOA, service-oriented architecture involves loosely coupled systems. All the functionality is encapsulated, which achieve specific results. These independent functions allow sort of reusability and configurability at each level. And by modularizing these tasks and exposes them at services, use cases we might not even know about where future integrations could happen, they can still happen. And now low-code platforms allow lots of these systems to be created independently through the use of pre-built functionality. So lots of these systems people have identified and created low-code tools which achieve these services. And then furthermore, these independent services can then be linked together with more low-code tools depending on the complexity of the problem like discussed. As the rule sets are defined between all the systems, it allows different levels of developers, programmers, and designers to integrate the systems without actually understanding each other at a very deep level. So with low code, the under the hood functionality of the stack is taken care of, and only the tasks logics need to be defined. So generic tasks can be taken care of by a service, and then customization can be taken place at limited integration points. Now, to give you another example, it's a bit like driving a car. So when you need to get to a destination, you don't need to take a look under the hood and figure out how the gear changing mechanism works or the internal combustion works. You just need to know how to change the gears, maintain the safe speed, and maintain control of the vehicle. So now you don't need to know how the tires work or how the gear works. You just need to know how to make them all work together to get to your operation. And now, in the spirit of sort of abstraction, in modern day driving, these tasks have been further abstracted. So the task of changing your gears has been taken over by automatic gearboxes. Cruise control takes over keeping your speed, and robots have taken over driving altogether. So now when you have to drive, you just get in a car and you go, I want to get somewhere. It doesn't matter how the car works, you just know how to get there. All right, so now to give you a more practical demonstration in line with sort of business, let's say I have a business that makes products. That's my specialty. And now there are a number of components that I need to fit together in order for my business to work. So that could be my sales and my accounting. And now I could choose to implement and develop the entire system. So I could create my own front end, I could create my own accounting management system, and these will all then need to be linked. However, let's just say I'm not used to front end or I have no clue about programming at all. I'll just use services that provide these things for me. So in the case of my customer-facing sales, I can use something like Shopify. Shopify takes care of the customer-facing really well. It works, I know this, and lots of other people have used Shopify. And then for my accounting, I can use something like Sage or Xero to reconcile all my payments, just because they do that really well and I'm not an accountant. I just make the products. So this is what typically happens in most enterprise systems, is that when using SOA, you end up with a whole load of third-party applications, and typically these are basically the most common vendors. So enterprises typically use services that are also used by the main industry players, and this leads to everyone having a whole load of sort of third-party services which all achieve specific tasks. But however, because they're all mainstream, they're not actually talking to each other. So what you end up with is a whole system with lots of different services which are modularized, etc. But you still need them to talk to each other. So now I'm stuck with a bunch of services that don't necessarily talk to each other, and I'm left with sort of sending spreadsheets and emails from department to department, and then I'm trying to reconcile everything, which obviously just leads a whole room for error. So now the task of updating each system, from the accounting system to the sales to my sort of inventory system, that still all has to be done manually because these systems don't talk to each other nicely. So I need to extract the data from one system, transform it, validate it, and then load it into another system, and that's how I create a system. But that's not very sort of system-wise, is it? That's a very manual process. And now this is where low code comes in. So I did mention low code has a variety of use cases depending on the complexity at hand. So let's take something like this on screen where I make an order and or I trigger an invoice and I want my HR department to know. And that's simply like a one-on-one connector. So I could use something like Zapier to create a connection that will send a notification when an invoice is created. But now say if I want to kick off a whole sort of workflow process at my factory, I could use something like Microsoft Forms Microsoft Flow, sorry, to integrate a whole level of approvals in order to make sure my document management is correct. But now, what if I wanted them all talk to each other? Well, then you go to the more complex aspect, which is application development platforms such as Linx, and then you can create a sort of a transformation layer that's really good at connecting all these systems from one system to another. So I could pick up a webhook from Shopify, which offers an API. I could store that in a database, link that with Sage, and then kick off a Zapier task if I want. So depending on how much you want to integrate and automate, the different varying levels of low code will suit you. All right, so now just to make this point again, I'm just going back to the slide to reinforce the strength of implementing service-oriented architecture with low code. So due to the high level of abstraction, services and tasks in a process flow can be modularized at a high level, and it means you don't really need to know the inner workings of that functional service or use case. Rather, you just need to know what data it takes in and what is the result. And this really helps in sort of designing applications, because the magic is the design really and less about the implementation of it. And with low-code tools, it helps you visualize your program a lot easier. All right, so now I've gone over what low-code SOA is. I'm just going to go over briefly some of the high-level benefits and risks of using low-code in businesses. So now, the major thing driving low-code adoption is the rate of the need for innovation. So modern companies need to innovate at a rapid pace to keep up with the market. New features are being developed every day, and customers want more and more new things. And now, in order for companies to keep up with this, low-code tools offer the solution. So when you need to create sort of rapid iterations of designs and get feedback on them, you can develop low-code applications almost immediately. So you can have an idea, development, and instead of 3 months down the line figuring out it won't work, you can know within an hour. Then a second big case of low-code in enterprise is automated testing. So low-code tools make it really easy to create automated tests that you can run again and again while having an underlying knowledge of programming. And these can either test legacy systems, any new systems, or any of your current work processes. Another area where it's of great use is rebuilding legacy apps. So legacy apps are often the first sort of applications or programs that these big businesses were running on. And these were often complex back in the day. And they've just been maintained the same as they is because they're too important, because everything is built on top of them. And low-code offers a great way to rebuild these things. So the technology was complex once upon a time when these systems were being created, but now we've abstracted these away, and you can build a lot of these low-level applications just with simple low-code apps. And then finally, task-specific apps. So low-code platforms allow you to build personalized apps at a very small scale, and this allows you to sort of automate tasks of your daily life away, say if you're in the accounting department or the advertising department, and you don't necessarily need to have a whole design system, QA, approval process, and get custom developers to make it. Rather, you can just make your app to make your life easier. So now I'm just going to make this point to this quote. Prolific developers don't always write a lot of code. Instead, they solve a lot of problems. The two things are not the same. So now I just want to make this point that low-code development is not a zero-sum game with traditional developers losing out. Instead, the two complement each other. So low-code doesn't replace the need for developers, it just assists them. And like in my point of view, the value of a developer is the quality of solutions delivered and not necessarily the code written. So the main value lies in the problem-solving ability of developer, whether they achieve a solution to a problem through coding it or with the assistance of low-code platforms. It doesn't really matter. Rather than just a solution, it works. So now, much like the typical development, the principle of don't reinvent the wheel should apply to low-code development. It functionally exists and has already been implemented. Why not use it? Much like we would in typical programming when you use someone else's package library. So with that in mind, this brings us on to the second biggest driver of low-code adoption, which is resource capacity. So now a major bottleneck in companies for innovation is resource capacity. So they don't have enough skilled developers to keep up with the rate of change because much of this time is spent maintaining existing systems. So here's some points around that. So senior developers, they're in short supply because the older you get, lots of people leave the coding world. And much of these guys' time is spent watching over lower level programmers just to ensure that they are following the proper procedures. And now their time shouldn't be spent doing this. It should rather be spent on core complex logic that they're better at implementing. But again, they don't have enough tasks to do this. Now, our second big resource strain is maintaining legacy systems. So like I mentioned before, you've got these old legacy systems that everything has been built off, and now they're too important to fail. So these very badly created systems have to be constantly maintained by developers in order for the whole system not to collapse. And now that's where innovation suffers, because if you don't have a research department, research and development department, and you're only spending your time maintaining systems, you're never going to create new ones. And this is where non-IT developers step in. So to free up the time, non-IT developers or subject matter experts, consultants, or designers, they can implement their own designs almost immediately, and they don't have to use any of these developers' times. So this really just frees up a lot for innovation. And finally, less testing. So as these systems or services that you use, their main focus, so therefore they've tested their product, you can assume they've tested it, that's their whole business. So therefore you'll spend less time either testing, and there'll be less time on bugs, etc., and you'll only have to deal with your business logic. Okay, so those are some of the advantages of using low code. And now I'm just going to go over the risks and considerations, like all things. So low code is not a silver bullet. And like all things in IT, there are a number of risks and considerations you must take into account before implementing a project, depending on a range of issues. And these can be briefly summed up in these four categories. So in terms of security, there are a number of considerations to be made when using services and low-code tools. Often it's, will these services be in your own environment, or will they have external access? And one of the things you must consider is what data is being passed through all these systems. Do you control that data? Is it confidential data or sensitive data? And how are you to trust that that service is handling the data correctly? Much like with confidential transactions, in terms of security, how are you sure that they are actually implementing the security up to your standards? And much of this is just trust. You just have to assume that it's up to your standards. If not, you go and you build your own. But like I said, because these people, it's a speciality, they're often up to scratch. All right, and now the second biggest consideration is the flexibility. So like I mentioned, there's a varying range of customization and flexibility with low-code platforms. So a big consideration is, if you are choosing a low-code platform or service, does it integrate with your existing systems? And how easy is it to expand? Because if you're stuck with a system that doesn't integrate, you're just going to keep on adding on all these external systems, which kind of defeats the whole point anyway. And then another thing with flexibility is getting locked in with a vendor. So if you choose a particular low-code vendor and there are issues with it on their side, you have to rely on their timelines to fix problems, etc. So if you're doing a very long project and something happens, you might not be able to get the thing you need in time because it's not on their priority list. And then finally, flexibility in terms of upskilling. So getting new users to use this new low-code platform might sort of constrain your resources a bit, and that's something to take into consideration. In terms of timelines, something to consider is if you're embarking on a massive long-term project or just a quick short one. So if you're embarking on a long-term one, there's a number of costs associated. There's a lot of features that you might know about, and some things might not be actually you might not be able to do lots of things, and you might only find out these later in the project. Whereas smaller, short projects, they're easily built, easily tested, and you can change if they don't work. And then finally, consideration is cost. So with most low-code platforms, the pricing and feature list is very ambiguous, and it's very unclear. So even with us, it's hard to make long-term decisions based on these things. So with typical programming, your only cost is your labor, where all the platforms are free. You'll have to sort of calculate all these different features you will need, and whether or not it can actually do the thing you want, because often this might just cost you more money than if you just hand-coded from the beginning.